Hello, fellow Kerbonauts. This is an 11-part, 0.226-ton propeller and rotor-controlled aircraft with no reaction wheel, landing gear, or elevons. Action Group 1 toggles propeller deployment. Action Group 2 resets the rotor's RPM. Axis Group up and down translation keys change the prop's angle. Main throttle is set to torque limit of both rotors. Roll axis group set to rotor's RPM limiter in an opposing incremental fashion. Both pairs of props are set to control pitch and yaw with an authority limit of 5 degrees. Roll is being controlled by the opposing RPM limit difference of the rotors. Action Group 2 resets the RPM limit to maximum for both rotors, as adjusting the roll with the roll axis group incrementally reduces the RPM limit of both rotors. SAS is essential for the vertical landing. Here, roll controls are being used to keep the solar panel facing the sunlight. The prop's authority over pitch and yaw controlling the angle of descent onto the VAB. Landing this craft with a Kerbal on the ladder is challenging, since a quick save and load will result in the Kerbal losing their grip. For convenience, a stage with a command seat was added to get Jeb on the ladder. The ladder and small probe body together weigh the same as the command seat. However, the Kerbal on the ladder is weightless and dragless while operating the drone. The small probe body also serves as this craft's battery. 2 winglets are essential without a reaction wheel, as there must be pitch and yaw stabilization with a lifting surface of some kind. To stabilize yaw, the winglets were angled up to 15 degrees. The winglets are also angled up slightly to generate lift while going prograde. This induces a slight amount of lifting drag, the only alternative being an asymmetric design using the 2 winglets. SAS hinders the performance of this craft during level flight, as the constant flux of the prop angles creates instability. Trim controls are being used to stabilize the craft. Here, pitch trim is activated by holding the Alt key plus the S key. To reset trim, press Alt plus X. Now the craft is using the pitch trim to cut into the atmosphere, leaving a trail of drag in the rear of the craft while also gaining altitude. Higher prop angles over 18 degrees cause the craft to drift left and right as the roll is corrected. After correcting the roll many times, the overall RPM limit between the 2 rotors has decreased and stabilized. Then the RPM limit is reset to max again, and the process continues. Here we can see that Jeb, being on the ladder, isn't registering any drag while operating the drone. The command seat still has its uses, however, like deploying the Kerbal's parachute, paramotoring, reliable quick saving, and handling high G-forces without losing the Kerbal. This tech could be used alone for a high-altitude drone perhaps, or to increase the performance of other designs. In comparison, this craft is only 1.14 times heavier than my minimalist asymmetric reaction wheel controlled design. I enjoyed the development of this craft, and it's also lots of fun to fly. I encourage all Kerbonauts to try the minimalist approach in KSP and in life. Thanks for watching.